We want to solve the absolute value of the difference of the absolute value of the quantity 2x minus 3 and 5 equals 10. Notice here we have an absolute value embedded within an absolute value. For the more basic absolute value equation, if we have the absolute value of x equals c, where c is greater than or equal to 0, we have x equals c or x equals negative c. We'll apply the same idea here, but we'll have to apply it once for the outer absolute value, and then once again for the inner absolute value. So going back to the original equation, let's first consider the outer absolute value. The expression inside the outer absolute value can equal positive 10 or negative 10. This gives us two equations. The first equation is the absolute value of the quantity 2x minus 3 minus 5 equals 10, or the absolute value of the quantity 2x minus 3 minus 5 equals negative 10. And now we need to take these two absolute value equations, isolate the absolute value, and set up two more equations for each of these equations. Starting on the left, to isolate the absolute value, we add 5 to both sides, which gives us the absolute value of the quantity 2x minus 3 equals 15. And then on the right, we add 5 to both sides to isolate the absolute value, which now gives us the absolute value of the quantity 2x minus 3 equals negative 5. Now we should recognize something here. An absolute value is always non-negative. It's never going to equal negative 5, and therefore we don't get any solutions from this equation. It doesn't mean there's no solution to the original equation. It just means you don't get solutions from this part. So now we go back to the left, and we set up and solve two equations for the absolute value of the quantity 2x minus 3 equals 15. Again, the expression inside the absolute value can equal positive 15 or negative 15, and the absolute value will still equal 15. This gives us 2x minus 3 equals 15, or 2x minus 3 equals negative 15. And now we solve these two equations. On the left, we add 3 to both sides. Simplifying, we have 2x equals 18. Dividing both sides by 2, we have x equals 9. And then on the right, we add 3 to both sides, which gives us 2x equals negative 12. Dividing both sides by 2, we have x equals negative 6. The original equation has two solutions, x equals 9 or x equals negative 6. Before we go, let's verify this graphically. To verify this graphically, we'll graph the left side of the equation, the right side of the equation, and then look at the x-coordinates of points of intersection. Using Desmos.com on the left, from the left side of the equation, we have y equals the absolute value of the difference of the absolute value of the quantity 2x minus 3 and 5, graphed in turquoise. And below we have y equals 10 from the right side of the equation, graphed in pink. Notice we have 2 points of intersection, and the x-coordinates do verify our solutions. We have x equals negative 6 or x equals 9. I hope you found this helpful.